An engineer is a practitioner of engineering, concerned with applying scientific knowledge, mathematics, and ingenuity to develop solutions for technical, societal and commercial problems. Engineers design materials, structures, and systems while considering the limitations imposed by practicality, regulation, safety, and cost. The word engineer is derived from the Latin words ingeniare and ingenium. The work of engineers forms the link between scientific discoveries and their subsequent applications to human needs and quality of life. A professional engineer is competent by virtue of his fundamental education and training to apply scientific method and outlook to the analysis and solution of engineering problems. He is able to assume personal responsibility for the development and application of engineering science and knowledge, notably in research, design, construction, manufacturing, superintending, managing of the education of the engineer. His work is predominantly intellectual and varied, and not of a routine mental or physical character. It requires the exercise of original thought and judgment and the ability to supervise the technical and administrative work of others. His education will have been such as to make him capable of closely and continuously following progress in his branch of engineering science by consulting newly published work on a worldwide basis, assimilating such information and applying it independently. He is thus placed in a position to make contributions to the development of engineering science or its applications. His education and training will be such that he will have acquired a broad and general appreciation of engineering sciences as well as a thorough insight into the special features of his own branch. In due time he will be able to give authoritative technical advice and to assume responsibility for the direction of important tasks in his branch. The above definition has been agreed by the Conference of Engineering Societies of Western Europe and the United States and by the Commonwealth of Engineering Conference. Roles and expertise. Design engineers develop new technological solutions. During the engineering design process, the responsibilities of the engineer may include defining problems, conducting and narrowing research, analyzing criteria, finding and analyzing solutions, and making decisions. Much of an engineer's time is spent on researching, locating, applying, and transferring information. Indeed, research suggests engineers spend 56% of their time engaged in various information behaviors, including 14% actively searching for information. Engineers must weigh different design choices on their merits and choose the solution that best matches the requirements. The crucial and unique task is to identify, understand, and interpret the constraints on a design in order to produce a successful result. Analysis engineers apply techniques of engineering analysis in testing, production, or maintenance. Analytical engineers may supervise production in factories and elsewhere, determine the causes of a process failure, and test output to maintain quality. They also estimate the time and cost required to complete projects. Supervisory engineers are responsible for major components or entire projects. Engineering analysis involves the application of scientific analytic principles and processes to reveal the properties and state of the system, device or mechanism under study. Engineering analysis proceeds by separating the engineering design into the mechanisms of operation or failure, analyzing or estimating each component of the operation or failure mechanism in isolation, and recombining the components. They may analyze risk. Many engineers use computers to produce and analyze designs, to simulate and test how a machine, structure, or system operates, to generate specifications for parts, to monitor the quality of products, and to control the efficiency of processes. Specialization and management. Most engineers specialize in one or more engineering disciplines. Numerous specialties are recognized by professional societies, and each of the major branches of engineering has numerous subdivisions. Civil engineering, for example, includes structural and transportation engineering, and materials engineering includes ceramic, metallurgical, and polymer engineering. Engineers also may specialize in one industry, such as motor vehicles, or in one type of technology, such as turbines or semiconductor materials. Several recent studies have investigated how engineers spend their time, that is, the work tasks they perform, and how their time is distributed among these. Research suggests that there are several key themes present in engineers' work: technical work, social work, computer-based work, information behaviors, amongst other more detailed findings. A recent work sampling study found that engineers spend 62.92% of their time engaged in technical work, 40.37% in social work, and 49.66% in computer-based work. Furthermore, there was considerable overlap between these different types of work, with engineers spending 24.96% of their time engaged in technical and social work, 37.97% in technical and non-social, 15.42% in non-technical and social, and 21.66% in non-technical and non-social. Engineering is also an information-intensive field, with research finding that engineers spend 55.8% of their time engaged in various different information behaviors, including 14.2% actively seeking information from other people and information repositories such as documents and databases. The time engineers spend engaged in such activities is also reflected in the competencies required in engineering roles. In addition to engineers' core technical competence, research has also demonstrated the critical nature of their personal attributes, project management skills, and cognitive abilities to success in the role. Types of engineers. There are many branches of engineering, each of which specializes in specific technologies and products. Typically, engineers will have deep knowledge in one area and basic knowledge in related areas. For example, mechanical engineering curricula typically includes introductory courses in electrical engineering and software engineering. When developing a product, engineers typically work in interdisciplinary teams. For example, when building robots, an engineering team will typically have at least 3 types of engineers. A mechanical engineer would design the body and actuators. An electrical engineer would design the power systems, sensors, and control circuitry. Finally, a software engineer would develop the software that makes the robot behave properly. Ethics. Engineers have obligations to the public, their clients, employers, and the profession. Many engineering societies have established codes of practice and codes of ethics to guide members and inform the public at large. Each engineering discipline and professional society maintains a code of ethics, which the members pledge to uphold. Depending on their specializations, engineers may also be governed by specific statute, whistleblowing, product liability laws, and often the principles of business ethics. Some graduates of engineering programs in North America may be recognized by the iron ring or engineer's ring, a ring made of iron or stainless steel that is worn on the little finger of the dominant hand. This tradition began in 1925 in Canada with the ritual of the calling of an engineer, where the ring serves as a symbol and reminder of the engineer's obligations to the engineering profession. In 1972, the practice was adopted by several colleges in the United States, including members of the Order of the Engineer. Education. Most engineering programs involve a concentration of study in an engineering specialty, along with courses in both mathematics and the physical and life sciences. Many programs also include courses in general engineering and applied accounting. A design course, often accompanied by a computer or laboratory class or both, is part of the curriculum of most programs. Often, general courses not directly related to engineering, such as those in the social sciences or humanities, also are required. Accreditation is the process by which engineering programs are evaluated by an external body to determine if applicable standards are met. The Washington Accord serves as an international accreditation agreement for academic engineering degrees, recognizing the substantial equivalency in the standards set by many major national engineering bodies. In the United States, post-secondary degree programs in engineering are accredited by the Accreditation Board for Engineering and Technology. Regulation. In many countries, engineering tasks such as the design of bridges, electric power plants, industrial equipment, machine design and chemical plants must be approved by a licensed professional engineer. Most commonly titled professional engineer is a license to practice and is indicated with the use of postnominal letters, P or PEng. These are common in North America, as is European engineer in Europe. The practice of engineering in the UK is not a regulated profession, but the control of the titles of chartered engineer and incorporated engineer is regulated. These titles are protected by law and are subject to strict requirements defined by the Engineering Council UK. The title CEng is in use in much of the Commonwealth. Many semi-skilled trades and engineering technicians in the UK call themselves engineers. A growing movement in the UK is to legally protect the title engineer, so that only professional engineers can use it. A petition was started to further this cause. In the United States, licensure is generally attainable through combination of education, pre-examination, examination, and engineering experience. Each state tests and licenses professional engineers. Currently, most states do not license by specific engineering discipline, but rather provide generalized licensure, and trust engineers to use professional judgment regarding their individual competencies. This is the favored approach of the professional societies. Despite this, however, at least one of the examinations required by most states is actually focused on a particular discipline. Candidates for licensure typically choose the category of examination which comes closest to their respective expertise. In Canada, the profession in each province is governed by its own engineering association. For instance, in the province of British Columbia, an engineering graduate with 4 or more years of postgraduate experience in an engineering-related field and passing exams in ethics and law will need to be registered by the Association for Professional Engineers and Geoscientists in order to become a professional engineer and be granted the professional designation of PEng, allowing one to practice engineering. In continental Europe, Latin America, Turkey and elsewhere, the title is limited by law to people with an engineering degree, and the use of the title by others is illegal. In Italy, the title is limited to people who both hold an engineering degree and have passed a professional qualification examination. In Portugal, professional engineer titles and accredited engineering degrees are regulated and certified by the Ordem dos Engenheiros. In the Czech Republic, the title engineer is given to people with a degree in chemistry, technology or economics for historical and traditional reasons. In Greece, the academic title of diploma engineer is awarded after completion of the 5-year engineering study course, and the title of certified engineer is awarded after completion of the 4-year course of engineering studies at a technological educational institute. Perception. Differences among countries. The perception and definition of engineer varies across countries and continents. British schoolchildren in the 1950s were brought up with stirring tales of the Victorian engineers, chief amongst whom were the Brunels, the Stevensons, Telford and the contemporaries. In the UK, engineering was more recently perceived as an industry sector consisting of employers and employees, loosely termed engineers, who included the semi-skilled trades. However, the 21st century view, especially amongst the more educated members of society, is to reserve the term engineer to describe a university-educated practitioner of ingenuity represented by the chartered engineer. However, a large proportion of the UK public still sees engineers as semi-skilled tradespeople with a high school education. In the US and Canada, engineering is a regulated profession whose practice and practitioners are licensed and governed by law. A 2002 study by the Ontario Society of Professional Engineers revealed that engineers are the third most respected professionals behind doctors and pharmacists. In the Indian subcontinent, Russia, Middle East, Africa, and China, engineering is one of the most sought-after undergraduate courses, inviting thousands of applicants to show their ability in highly competitive entrance examinations. In Egypt, the educational system makes engineering the second most respected profession in the country. Engineering colleges at Egyptian universities require extremely high marks on the General Certificate of Secondary Education, on the order of 97 or 98%, and are thus considered to be among the pinnacle colleges. In the Philippines and Filipino communities overseas, engineers who are either Filipino or not, especially those who also profess other jobs at the same time, are addressed and introduced as engineer, rather than sir, madam in speech or Mr., Mrs., Ms. before surnames. That word is used either in itself or before the given name or surname. French ingénieur title. It is sometimes told by urban legends that in France, the ingénieur title refers only to membership of the French executive elite and has no relation to technological skills. This is false. Engineer is the title of someone who succeeded in engineers' schools. There are many different kinds of engineer schools in France like in other countries. Some engineer schools are more famous than others. Examples of French famous engineer schools are Polytechnique, Supélec, Institut National des Sciences Appliquées, Institut Mines Télécute l'Écute com, École Nationale Supérieure des Métiers, École Centrale Paris. Polytechnique and ENSAM have their roots in the French Revolution, and some of their alumni become famous either as scientists, CEO of international companies, or as politicians. Polytechnique is even different of other engineer schools as education lasts 6 years instead of 5, with the last year being of specialization in one specific technique. It is also a military school. Most schools of higher education that were created during the French Revolution have a special status in French people's mind. They helped to make the transition from a mostly agricultural country of late 18th century to the industrial state that France was in the 19th century. A great part of 19th century France's richness was created by engineers coming from Polytechnique or École des Mines. This was also the case after the World War II, when France had to be rebuilt. Before the Réforme René Haby in the 70s, it was very difficult to become a French engineer. Nowadays, after the Haby reform and a string of further reforms, modernization plans of French universities, it is much more common to access those schools, and the French elite comes more from École Nationale d'Administration for managers or politicians and École Normale Supérieure for scientists. Engineers are less highlighted in current French economy as industry provides less than a quarter of the GDP. Corporate culture in companies and other organizations. There is sometimes a tendency to undervalue people with advanced technological and scientific skills compared to celebrities, fashion practitioners, entertainers and managers. In his book The Mythical Man Month, Fred Brooks Jr. says that managers think of senior people as too valuable for technical tasks, and that management jobs carry higher prestige. He tells how some laboratories, such as Bell Labs, abolish all job titles to overcome this problem. A professional employee is a member of the technical staff. IBM maintain a dual ladder of advancement. The corresponding managerial and engineering, or scientific rungs are equivalent. Brooks recommends that structures need to be changed. The boss must give a great deal of attention to keeping his managers and his technical people as interchangeable as their talents allow.